So for the first problem, it is a continuous function, so you just plug in. And if you plug in 1, you get out 4. In the next one, sine is a continuous function. So again, you just plug in. You could calculate that as a decimal if you like, but really just leaving it as sine of 1 is as good as anything else. Now, tangent, if you recall, is equal to sine over cosine. And this is going to be continuous everywhere except at pi over 2, negative pi over 2, and everywhere else that cosine is equal to 0. Well, since we're not plugging in any point like that, we have a point of continuity, and the answer is just tan 1. Here, we would like to factor. We're definitely working with a point of discontinuity, so we try to factor. It's pretty easy. It's just x minus 1 squared. And we cancel a factor and get that the function is equivalent for non-1 values, which, because we're taking a limit, that's what we're doing. It's equivalent to x minus 1, and this we just plug in 1 and get 0. So the answer here is 0. Now here, as x approaches 1, this is a continuous function at that point, so you just plug in 1 and you get 1 over 1. Here, it is not a continuous function where the argument is 0, right? And since we're approaching 1, that makes the argument 0. This is a discontinuous function, and as we've seen before, the limit where the argument goes to 0 does not exist because of the left-handed limit. Or really, in this case, it would be because of, it would still be because of the left-handed limit. So here, the limit does not exist. The right-handed limit is equal to 0. You could sort of convince yourself of that graphically or some other way, but the limit does not exist. Here, the same basic story holds, right? There is no left-handed limit because we know that ln does not have left-handed limits where the argument approaches 0. The right-handed limit would be negative infinity, though, if you wanted to talk about the right-handed limit. Since that's not what the question is about, you don't have to say anything about that. Anyway, here we have, again, a situation where we can factor and cancel. I did basically that in the demonstration video, and I've solved, in fact, I solved both of the, these practice problems in a previous video, so I'll just leave those for you to check that video. In this case, we are given that the limit of f of x as x approaches 2 is 10, and the limit of g is negative 5, and we want to find these two limits. Well, we can distribute the limit, right? The point of this exercise is basically that limits distribute, so the limit of 2f minus g, I'll abbreviate it, is 2 times the lim of f minus the lim of g. I have just distributed the limit. I've distributed it over the negative, over the minus sign. And then I've also distributed it over the times 2. So I've moved that times 2 to the outside of the limit, right? Initially, everything's inside the limit, and now I've distributed the limit as far as I can so that now it's just the limit of these sort of bare functions, so to speak. And now I can use the fact that the limit of f is equal to 10 and the limit of g is equal to negative 5. Now I can compute that and I get 20 plus 5 is 25. Down here, I have a harder problem where it says let f be the piecewise defined function, which is 2x plus c when x is less than 2, and this other thing when it's greater than or equal to 2. Find the value of c which makes it continuous. Well, recall what continuity means. It means that the left-handed limit, the right-handed limit, and the value at the point are all equal. Particularly the value at the point 2 is easy to find. That puts us in this clause because we have a value equal to 2. We plug in and we get 5. So I know that the left-handed limit, the right-handed limit, and the value all have to equal 5. But the only other problem spot comes from the left-handed limit, because that's where we're dealing with this clause. So I know that the left-handed limit of this needs to equal 5. So what is the left-handed limit of this? Well, lim of 2x plus c, by what we did sort of in the previous problem, is going to be, here I'm taking the limit at 2, so I just plug in and I get 4 plus c. This tells me that therefore c equals 1, right? So we know that 5 is equal to 4 plus c, and if you subtract the 4 to the other side, you get that c is equal to 1. So by choosing c equal to 1, we have all of the limits and values agree, and that makes it continuous. Okay. Is this function plotted below continuous at 0? It sure looks like it. The left-handed limit is equal to the right-handed limit, and if there's any gap in the function, we sure can't see it. Is it continuous at 1? It certainly looks like it is yet again, because the left-handed limit, the right-handed limit, and the value of the function at the point all seem to agree. So, in fact, the answer to both of these is yes.